Welcome again, students. In the part B of this revision lecture, we will now discuss with you the question of the salibi asked in the year ISC Questions, ISC board in the year 2015. So, these 4 chapter questions which were asked in the year 2015 will be discussed now. Question number 1. Question number 1 is complete the following statement by selecting the correct answer. The A is molar freezing point constant for water is 1.86. Kf is given 1.86. Kelvin kg per mole. Their freezing point of 0.1 molar solution. Kelvin kg per mole. We have to find out freezing point of 0.1 molar solution. Delta Tf we have to find out. Molality is given as 0.1 molar for NaCl solution. We have to find out freezing point. We know delta Tf will be equal to freezing point of solvent minus freezing point of solution. Therefore, the freezing point of 0.1 molar solution in water is expected to be. So, we have to find out this. Yes? Now, what is the formula? Delta Tf will be equal to I into Kf into molality of the solution. This will be equal to NaCl for I will be 2, Kf will be equal to 1.86, molality will be equal to 0.1. Yes? Then the freezing point of NaCl will be equal to delta Tf minus freezing point of the solvent. So, freezing point of solution will be equal to freezing point of solvent minus delta Tf. This will be what? Water at 0 degree C minus 2 into 1.86 into 0.1. Solve it out, it will come out to be equal to minus 0.372. It is quite imperative from this one, 0.372 degrees C. So, what will be the answer over here? Answer will be second. Is it clear? Second answer is the correct answer. What option will be given over here in the answer? Second is an answer. This is multiple choice questions. Now look at the B part. B part of the question. For the first order reaction, the rate constant for the decomposition of N2O5 is 6 into 10 raised to power minus 4 second. K is given as 6 into 10 raised to power minus 4 per second. The half-life period for the same will be T half will be equal to 0.693 upon K. This will be equal to 0.693 upon 6 into 10 raised to power minus 4. Solve it out and the answer to this will be 1155. So, option C is the correct answer. Am I clear? Now the third part. Here option B, second was the correct answer. Here C is the correct answer. Third part or option C. When acetaldehyde is treated with Grignard reagent, the product obtained will be acetaldehyde. When react with Grignard reagent, the product obtained will be, this will add to this side, MgI will add to this side. It will result in the formation of addition product CH3C, H, CS3 and then OMgI. This compound when hydrolyzed with water in presence of acid. This over here will be OH. The product obtained will be CS3, then CH, CS3 and OH minus magnesium hydroxyiodide. So, it will result in the formation of 3 degree alcohol. So, what is an answer over here? I am sorry, 2 degree alcohol. Is it clear? So option over here will be B. Acetaldehyde will give secondary alcohol. So what is an option in the question? B. Here the option was C. Here the option was second. Here in this case, option was B or second. Am I clear? So these were 3 multiple choice questions in the paper in the year 2015. Now question number 2. Question number 2, A part. 2 liquid A and B form type second non-ideal solution which shows minimum in its temperature mole fraction plot. Can the 2 liquid be completely separated by fractional distillation? No. Minimum boiling azeotrope means minimum boiling which shows minimum in its temperature. Minimum in its temperature means it's a minimum boiling azeotrope. Azeotropic mixture cannot be separated by fractional distillation. So what will be the answer? No. If someone asks you why, as it is a azeotropic mixture. As it is a azeotropic mixture. As it is an azeotropic mixture. Since it is an azeotropic mixture, so it will not form this. Yes? B part. What is Lucas reagent? A mixture of concentrated HCl and anhydrous zinc chloride is called as a Lucas reagent. So Lucas reagent. Lucas reagent is concentrated HCl plus anhydrous zinc chloride is a Lucas reagent. Is it clear? Now let us look at the next question. Next is a solution containing 0.5 gram of KCl. Question number 3, a numerical portion. Question number 3 over here. A solution containing 0.5 gram of KCl is dissolved in 100 gram of water and freezes at minus 0.24 degrees C. Calculate the degree of dissociation of the salt. So we have to find out alpha over here in the degree of dissociation of the salt. Just see over here, solution containing 0.5 gram of KCl, mass of KCl is given as 0.5 gram, is dissolved in 100 gram of water, W is 100 gram, and freezes at minus 0.24 degrees C. So freezing point of solution is given. It is minus 0.24 degrees C. Calculate the degree of dissociation of the salt. Alpha we have to find out. Am I getting clear? Now we have mass of the solute given. We have a formula delta TF will be equal to I into KF into W upon M into capital W into 1000. Yes or not? In fact, let me first of all find out the molecular mass. This is given to us 0.24 delta TF. So this will be 0.24 will be equal to value of KF is given as 1.86 into 0.5 upon M, weight of solvent is 100 into 1000. Solve out, it will come out to be equal to 38.75. Now I, because for finding out the degree of dissociation, we have to find out the value of alpha. I will be equal to normal molecular mass. Normal molecular mass upon observed molecular mass. What is normal molecular mass of KCl? It will be 74.5. Observed molecular mass 38.5. It approximately comes to be equal to 1.92. Tell me whether it is clear or not. Now what you have to find out? You have to find out the value of alpha. What is the value formula for alpha? Alpha will be equal to this I will be equal to. We have KCl, na? So KCl will ionize to form what? Potassium ion and chloride ion. If it is 1 minus alpha, this will be alpha, this will be alpha. So I will be equal to observed moles of solute upon normal moles of solute upon initial moles. Observed mole will be how much? Observed moles. This will be equal to 1 minus alpha plus alpha plus alpha. So this will be equal to 1 plus alpha. So it will be equal to 1 plus alpha upon 1. Yes, but I value is what? 1.92. So 1.92 will be equal to 1 plus alpha upon 1. Solving for alpha, it will come out to be equal to 92%. So alpha will be equal to 0.92 or 92%. Am I clear? So you have seen that the question on abnormal colligative property are common features of the board examinations. Now question number 3, second part. 1.7 gram of sugar are dissolved in 500 ml of aqueous solution. What will be its osmotic pressure? What is the formula? Pi is equal to N upon V into R into T or S into T, whatever you want, the value remains same. Question is, what will be its osmotic pressure? This will be equal to what? Given mass upon molecular mass into volume into S into T, or you may take R, because I have been regularly teaching you by the value of R. What is the given value of W? It is 1.71. 1.71. Molecular mass 342 in 500 ml. 500 ml divided by 1000 into 0.0821 in liter atmosphere per Kelvin per mole into 300 Kelvin. I think I shall be very clear. One thing I have done, I have converted the volume into liters. So on solving it out, it will come out to be equal to 0.246 atmosphere. Yes? Now the third part. What is the third part of the question? It is given as 0.70 gram of an organic compound when dissolved in 32 gram of acetone produces an elevation of 0.25 degrees C in this boiling point. Delta TB is given 0.25 degree C. Weight of solute is given 0.70 gram. Dissolved in 32 gram of acetone, capital W is given 32 gram. Calculate the molecular mass of the organic compound. M is to be calculated. If delta TB, if KB is given, it is given as 1.72 Kelvin kg per mole. 1.72 Kelvin kg per mole. Quite simple. Delta TB will be equal to KB into molality of the solution. This will be equal to KB into WB upon MB into WA into 1000. This is delta TB. Simply put on the values. This is 0.25 will be equal to KB 1.72 into weight of solute 0.70. Molecular mass of the solute is to be determined. Weight of solvent, weight of acetone is given as 32 into 1000. From here, you may find out the molecular mass of the solute. Am I getting clear? If you find out the molecular mass of the solute, on solving it out, it will come out to be equal to 150.05 gram per mole. I think I shall be very, very clear. Now the next question is, what is the difference between the order of the reaction and the molecularity of the reaction? This is a question number 3rd in your paper. This is question number 3rd, B first. Difference between the molecularity and order of the reaction. I think I have done this many times. Order of the reactions are experimentally determined. Molecularity is a theoretical concept. Order of the reaction can be 0, negative, fractional, positive, anything. Molecularity cannot be 0, negative, fractional, or this value over here. Is it clear? Then what is order? It is equal to the sum of the power of all the concentration terms in the slowest rate determining step of the reaction, that is in the rate law expression. And what is molecularity? It is equal to the total number of a simultaneous collision in the chemical equations. Then next one, second part. So first part is clear, difference between order and the molecularity of the reaction. I think it is clear. I must solve the second part for you. Second part. A substance decomposes by following the first order reaction. 50% of the compound is decomposed in 120 minutes. How long will it take for 90% of the compound to decompose? So K will be equal to 2.303 upon T log base 10 A upon A minus X. It is given 50% of the compound is decomposed in 120 minutes. So K will be equal to what? 2.303 upon 120 log base 10. 50% is decomposed now in 120 minutes. So this will be equal to 100 upon 50. From here you find out the value of K. And it will come out to be equal to 5.77. 5.77 into 10 raised to power minus 3 per minute. You could have easily find out by using the half-life formula. T half was equal to 0.693 upon K. Then the part is, how long will it take for 90% of the compound to decompose? So again, T will be equal to 2.303 upon K log base 10 A upon A minus X. This will be equal to what? 2.303 upon 5.77 into 10 raised to power minus 3 into log base 10. So putting on the values, when 90% is decomposed, it will be 2.303 upon 5.777 into 10 raised to power minus 3. Solving it out, answer will come to be equal to 399 minutes. Is it clear? Now question number 4. Just see very quickly, because you know this. How can the following conversion be brought about? Chlorobenzene to phenol. A part. Chlorobenzene, when made to react with aqueous NaOH, it will result in the formation of sodium phenoxide. Sodium phenoxide, when hydrolyzed with water, acid, it will result in the formation of phenol Daw process. Yes? Diethyl ether to ethanol. Second part is diethyl ether to ethanol. Diethyl ether to ethanol. Again the reaction is very simple. Diethyl ether, when made to react with hydrogen iodide, it will result in the formation of ethyl iodide plus ethyl alcohol will be given out. It depends on the hot and the cold condition. It can only be the product ethyl alcohol. Then phenol to aniline. Phenol to aniline. We take phenol molecule. on reaction with zinc dust, it will result in the formation of benzene. Benzene on reaction with chlorine in presence of ferric chloride, it will result in the formation of chlorobenzene. This on reaction with ammonia, it will result in the formation of aniline. We have done these reactions earlier also. So product obtained will be aniline. Question number 5. You may also carry out the reaction with sodamide, NaNH2. How can the following, how is iodoform prepared from ethanol? Give balanced equation. I think we have done this. Ethyl alcohol plus iodine plus a sodium hydroxide. It will result in the formation of a iodoform. This question we have done many times with you. So I don't think we need to repeat it up. What will be the product form when chlorobenzene is treated with sodium metal in the presence of dry ether? In the previous reaction we have done this. It was a Fittich reaction. Second part is this iodoform test you can do. So iodoform. I think you can write down this reaction. Ethyl alcohol plus iodine and sodium hydroxide. It will result in the formation of a iodoform. Is it clear? Or if I write down this reaction, ethyl alcohol with sodium hydroxide you can do, with a sodium carbonate, or with iodine and sodium hydroxide. Writing down the reaction, it will result in the formation of iodoform. What color precipitate will be obtained? Yellow precipitate. Yes, plus sodium formate, sodium iodide, and water molecule will be given out. Plus sodium formate plus sodium iodide will be given out along with a fine molecule of water. This is the iodoform reaction. Then chlorobenzene is heated with sodium metal. B part. Chlorobenzene is heated with sodium metal in presence of dry ether. 2 molecules of chlorobenzene when react with sodium metal in presence of dry ether. What will be the product obtained? It will result in the formation of a biphenyl compound plus NaCl. The balanced equation for Reimer-Timer reaction. Question number 6. A part. Phenol on reaction with chloroform in presence of sodium hydroxide followed by hydrolysis in presence of this. It will result in the formation of orthohydroxybenzaldehyde. This is Reimer-Timer reaction. Reimer and Timer reaction. Is it clear? Wood's reaction, we know. Methyl chloride, when react to react with sodium metal, 2 molecules of methyl chloride will react with sodium metal in presence of dry ether. It will result in the formation of a ethane molecule plus sodium chloride will be given out. This is how it is to be done. So we have in this last revision before the first term examination have done with you the revision of the paper 2016 and 2015. Now I hope you will be doing well in your first term examination. Please revise your chapter thoroughly. Best of luck to you. Thank you.